my favorite country to visit in the future, to see how how Nigerian economy especially
Okay.
is it in Africa. Okay, if you talk about Nigeria, in Africa, Nigeria, what is, if I rank it to 1 to 10, Nigeria is number what in Africa in terms of the economic growth, GDP.
In terms of GDP.
I'm talking about if I rank it 1 to 10. Okay, Nigeria. What numbers of Nigeria? Okay, amongst the Nigerian Africa country. You don't know?
And Nigeria should be among the first 10.
Okay, good, very good. So your country, because the main GDP contribution from oil, correct?
Yes, from crude oil.
Yeah, from crude oil. Yeah, I know that. Yeah. Okay, so actually we are still in the cost minimization. Okay. And sorry. This one is chapter. We are in the chapter 7. Okay, we are in the chapter 7. Wait a minute. We are in the chapter 7. We are in the chapter 7. Where is my slide? Come on. Wait a minute. Okay, this one is okay. Cost minimization, cost and cost minimization. This one chapter 8. This one is chapter 8. What happened? Anybody can help me? Why I cannot open my slide? Hello class, can you see this one? You can see, isn't it?
Yes, bro.
Yeah. This one is chapter 7. Okay, this one is chapter 7. Okay, this one is chapter 7. Okay, chapter 7. Last week we finished chapter 7 or chapter 6? Anybody can help me? Help me to. I didn't remember what was the last topic we discussed last week. Is it in chapter 6 or chapter 7? Chapter 7, correct? Hello class, chapter 7, correct or not? Class?
Yes, bro. Chapter 7.
Yeah, chapter 7. So, we have done this discussion. Yeah, we have done this until corner solution, I think so. Comparative static also we have done. So, okay, what about this one? Comparative static. Okay, if you talk about the comparative static, okay, look at this one. If R equal to 1, okay, R is the price of capital. And if Q, okay, Q0 is here, okay, Q0 is here, okay. So Q0 is quantity of output. Okay, this is constant. Okay, look at the graph here. The red color is constant. Okay, is constant. And this is also, we call it isoquant. Okay, look at here. When price of capital equal to 1, okay, price of labor also equal to 1. Okay, this is isocost. Okay, this is C1 here. Okay, C1 here. Okay, C1 here. So W equal to 1, this is cost of labor. R equal to 1, this is cost of capital. Okay, so optimal should be here. Why the optimal should be here at A? Because Okay, the isoquant touch, okay, isocos. So the tangent of isocos, this one is isocos, and it is isoquant at A. So optimal, this is optimal to produce Q0. You will hire, sorry, okay, the firm will have K1 and L1. Okay, so what happened if W increase to 2? W increase to 2. Now, in this particular isocos, W equal to 1. So what happened if cost of labor increase to 2? Okay, anyone can tell me if labor cost increase to 2, what happened? Don't see the graph. Okay, please don't look at the graph. Okay, please don't look at the graph. Okay, so if labor cost increase to 2 from 1, what happened? Anybody can tell me? Hello class, anybody can explain to me? Don't look at the graph, please. Anyone can explain to me? Class. Hello class. Class, anybody in the class?
Yes, Prof.
Also, why so quiet? Why so quiet? It's very simple question. Okay, so cost of labor now is 1. Let's say cost of labor increase to 2. So can anybody explain to me what happened now?
Capital will increase.
Why capital will increase? Why? My question is why capital is increased?
Because the labor is increased.
No, because not the labor is increased. Labor, if you said capital is increased, if capital increase, labor cannot be increased because capital and labor cannot. If the changes is proportionately similar, or not proportionately similar. So if capital increase, labor cannot be increased together. Anyone can explain why capital and labor cannot increase together? Why?
Prof, maybe because when the price of labor increase, so the labor that we purchase maybe is high quality. So that means that the labor services that are needed to be used is decreased, but the service that they give, which is the capital, it increase. Is it right? Not sure.
Not really correct. Okay, but good. You try it. Good, very good. Okay, anybody want to try?
Prof.
Yeah.
How about because of wanted to minimizing cost of production?
Yeah. So my question is, okay, look at here. Okay, now we are using labor when cost of labor is 1. Okay, what happened if now cost of labor is 2? So when cost of labor is 2, what happened? This is my question. Okay, very simple. Okay, if look at here, cost of capital is 1, cost of labor is 1. So this is similar proportion. Okay, similar 1, 1. Okay, if cost of labor increase to 2, meaning that double. Cost of labor double now. Cost of labor double. From 1 to 2, double. Double. So if cost of labor double, firm will hire more capital at here and will reduce labor from here to here. From here to here. Or from here, from here to here. Okay, I repeat. Okay, when when cost of labor double to 2, firms start to decrease using of labor from L1 to L2. Okay, however, because cost of labor increase, so cost of labor increase, cost of capital still one. Only cost of labor decrease double. Meaning that this firm will hire more capital from here to there. So now we have a new ISO cost here. This we call is C2. C2 actually is look at the different. This one C1, this one C2. C2 actually is when cost of labor equal to 2 and cost of capital still 1. Cost of capital constant, fixed. However, cost of labor increase to 2. So now we have a new tangent here. Okay, this is a tangent of isoquant and isocost. So meaning that this firm start to produce in here Q0. However, please production of A and B are the same. Why? Because we are in the similar Q0 isoquant. You produce here or you produce here, the costs are the same. Okay, the costs are the same. So in here you use more capital, less labor. In here you use less capital and more labor. Okay, any question please? Okay, any question please? Any question please? Please, anybody has question please? Any question please? Hello class.
No, Prof.
Do you have any problem? Do you have any question? Yes or no? Understand or not? Because next slide, okay, not slide, okay. In chapter 8, okay, we will apply it to many graph. So hopefully you understand it now. Otherwise, you have a difficulty to understand chapter 8. Because chapter 8, the graph become more complicated. Okay, become more complicated. Okay, any question please? Okay, any question please? Any question please?
No problem.
Good. Okay. Okay, now we go to the next slide. Okay, look at the next slide. Okay, the next slide. This is the some key definition. Okay. So, okay, one of very important in real situation is expansion pass. Okay, we talk about inspection pass is before. Okay, before. The second one is normal input. The third one is inferior input. Okay, so look at what the this from the graph. Look at here. Okay, remember Okay, when we have optimal A, optimal B, optimal C, we have different output, 100, 200, and 300. And we have different ISO cost. Okay, this is the first ISO cost, second ISO cost, and third ISO cost. So A is optimal when Q is 100. B is optimal when Q is 200. And C is optimal when Q is 300. So if you connect, okay, connected between A, B, and C, it becomes expansion path. Okay, any question, please? Okay, in other words, expansion path telling you what? Anybody can explain? I repeat my question. Actually, expansion path telling you what? Telling you what? Anybody can explain to me? What is expansion path? Telling you about what?
Maybe it shows the optimal points, the ideal optimal points.
Okay, look at the movement here. Okay, the movement here. The movement here. So the movement here is from A, B to C. So you connect each other, become expansion paths. So we have different Q and we have different ISO costs. Okay, and we have different combination of K and L. This one K1, L1, this one K2, L2, and this one K3, L3. So expansion path telling you, can anyone continue my statement?
Easy.
Okay, expansion path telling you,
Optimal input.
no, actually, it tells you, okay, if you want to increase your optimals, okay, optimal, we're talking about it here. Remember optimal, this one we call it as, okay, optimal, where is the optimal? Here, this one is not, that is, yeah, optimal, this one, okay, optimal of production. Okay, if you want to increase your optimal of production, this one is increase of optimal of production. Okay, you can increase it by increase your K proportionately, the same as you increase in L. This one is proportionately. For example, okay, maybe this one is the gap here is look like, okay, not too much, and the gap here it looks like more. Okay, so if you want to increase to here K, at the same time you can increase also L1. Okay, so if you increase more K, you can increase more L. So the new isocon here, this is your new output. Okay, new output. You cannot increase output. Okay, this is expansion path. You cannot increase output without, okay, without increase K and L. That is the meaning of expansion path. Okay, the more the direction is here, the direction is here. Okay, the more you hire capital, the more you hire L, the more you produce output. Okay, so expansion path will increase. Okay, this is the meaning of expansion path. Okay, look at here. Expansion path can be looks like here. Okay, there is difference between here. This one is looks like, okay, look like positive. Okay, however, this one is look like negative. Okay, look like negative. Okay, look like negative. Look at Q. Q is 100 here and 200 here. Q is, okay, 100 here, 200 here. Okay, why do you think, okay, anybody can explain to me, why do you think expression path look like this? Anybody can tell me? Hello class. What is the difference between this expression path and this expression path? Actually, you can increase Q to 200, the same as here. You increase Q 100 to 200. However, you have this kind of expression path compared to this expression path. What is the difference? Okay,
Because
anybody can tell me? Okay, what is labor is an inferior input? Okay, the word labor is an inferior input. What is meaning by labor is an inferior input? Hello class. What is labor an inferior input? Class, don't be quiet. You should give your opinion.
The labor is not efficient in their work.
No, no, this is not the answer. Others?
Prof.
Yes.
Maybe because labor, as time goes by, labor become a company doesn't use labor as much as before. So it become inferior.
Okay, others try it. Okay, if you compare this expression path and this expression path. Okay, there are two expression paths here, this one and the other one. Okay, which one is the best expression path? Okay, I repeat. Which one? Either this or this. That's the best expression path.
First one.
Second or the first one? Second or the
First
first?
one.
First one here. This one is the best.
Yes,
You agree or not? Yes or not?
agree. This one.
Agree. Okay, why? Why this one is the best?
Maximum use.
No, this is not the answer. Okay, look at the cost. Look at the cost. If you have this kind of expression path, you increase L, you increase K, your output increase to 200. Correct or not? Yes or no? Hello class, yes or no? I
Yes.
Yes. Look at this one is optimal A, this one is optimal B. If you want to achieve optimal B, you must increase K2, you must increase L2. Look at here. If you want to have optimal B, this one is optimal A, this one is output 100, this one is output 200. This one is better than this one. Why? Because it is 200. This one is 100. However, look at here. You use less labor. you use less labor. At the same time, you use more capital. And that is what we're talking in here. In here. In here. Between A and B, which one is the best?
The B.
No, you cannot say that. because both A and B are optimal. And they produce same output. The difference is combination of capital and labor. This combination A2, L2, you produce B. Okay? At A, the combination is K1, L1, but still Q equal to 0. However, in here, we are different. Combination B, K2, L1. Okay? Combination A optimal, K1, L2, but you produce better here. So meaning that B is better than A. So you minimize the cost. So in this particular graph, telling you this expression pass is minimize the cost. Any question, please? This is we call is minimization, cost minimization pass. Okay, any question, please? Anyone
Prof,
understand?
in these slides, does it mean that the price of the labor increases, which makes
Yeah, the same as
becomes to be?
yeah, the same as here. The price, the cost. We not talk about the. Okay, you can because when we talk about the labor, we talk about price of labor, isn't it? Okay, you can say that. Okay, price of labor increase. So that's why you hire less labor. However, when we talk about the capital, price of capital remain the same, fixed. So you actually can hire more capital at the same cost. R1. So, okay, when you explain this, the same thing. Okay, because the cost of capital remain the same. Only the cost of labor decrease, price of labor decrease, price of capital the same. So you hire more capital. So actually you hire less labor. So you minimize the cost. So be optimal at minimize the cost. Okay. Anybody still not understand? Please. Anybody still not understand? Anybody feel still blur? Okay or not? You understand or not? If you understand, I will proceed to the next slide. Hello, class. Class.
It's understood.
Understood. Good. Okay, good. Okay, now we talk about the input demand. Okay, this is very common to you. Okay, so what is input demand? Okay, input demand, capital and labor, please. We talking about capital and labor. This is input. Okay, this is input. So when we talk about definition of input demand, so it tells us firm cost minimizing. Okay, cost minimizing quantity of input, capital or labor. When we talk about input, there is KL, varies. Okay, varies, not fixed, varies with the price of that particular input. Price here either W or R. Please remember, price of capital is R. Price of labor is W. Please remember this because we will talk about this price for the next chapter, chapter 8. So, we have two inputs, labor and capital. Labor is L, capital is K. This is the symbol. So when you talk about labor demand curve, L, so actually it show firm cost minimizing. Using labor, higher labor depend on price of labor. What is the price of labor? What is the symbol price of labor? Plus W, yeah. W. So labor demand curve, show the firm cost minimizing quantity of labor. How many labor should they hire? Depend on W. So what is capital demand curve? Capital demand curve is how the firm minimizing cost using capital K. How many K should be higher? How many K should be higher? Depend on what? Depend on what is the symbol? What is the symbol? Depend on what? Class. Depend on? Hello class. Depend on? Hello. Depend on? R. Good. Please. R. Remember, R is the price of capital. Okay. Now look at this one. This one is K. This one is price of wages. Okay. This one is labor. Okay. This one is wage. This one is L. This one is K. This one is price of labor. Okay, and this particular, look at this particular here, we start in here, W1R1. Okay, W1R1, W2 divided by R, W1 divided by R, and W3 divided by R. Okay, we have 3 points here. Please remember, we have 3 points. 1 point here, 2 point here, third point here. And the quantity is Q. Fixed, constant. Okay, now look at labor. Okay, labor. Labor will be varies. L1, L2, L3. Okay, L1, L2, and L3. Okay, in here, look at here. Okay, this is, W divided by R, but this one is W3. R constant. Okay, in here, actually is in here. In here is W2. This one is W2 divided by R. R constant. And here is W1. Okay, R constant. Only wage, W where is? Okay, because we have different labor. Labor 1, labor 2, labor 3, labor 1, labor 2, and labor 3. So look at the demand curve for labor. This is the demand curve for labor. This is what we call is labor demand curve. Labor demand curve. So labor demand curve is something like this, negatively slope. Okay, anybody can tell me why negatively slope? Yeah, why demand curve is negatively slope? Anybody can tell me why demand curve is negatively slope? Hello class. Why demand curve negatively slope? Anybody can tell me? Explain to me why demand curve is negatively slope. Look like this. There is, negatively slope. Why negatively slope? Demand curve. Hello class, try it.
The more the labor, the decrease in wages.
No. No, why I said no? Because when wage increase, W increase, what happened to the labor demand? I repeat, when wage increase, what happened to the labor demand?
Decrease.
Increase.
This decrease. Decrease. Labor demand will decrease. Why the labor demand will decrease? Okay, look at during COVID-19. Okay, now we have COVID-19. Okay, COVID-19. Do you think, okay, what happened to labor demand? We have labor demand less or we have the labor demand more during COVID-19? Anybody can guess?
Less.
Why? 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 Please, why? Okay, when you give me an answer, I will ask you why. Okay, look at during COVID-19. Okay, during COVID-19, okay, do you think some sector, okay, some sector produce more and some sector produce less? Okay, I give you example. For example, I'm talking about the glove sector, because when we have COVID-19, glove become very important. Glove mask, very important. So demand for glove and demand for mask increase. When demand for glove and demand for mask increase, production increase. When production increase, what happened to the labor demand? What happened to the labor demand?
Will increase.
Increase, good. What happened to the W?
Decrease.
Increase or decrease?
Will decrease.
Will decrease. But please remember, in the world, we have minimum wages, including Malaysia. Okay, in Malaysia as well, we have minimum wages. In Malaysia, our minimum wage is RM1100 per month. Okay, so actually, in Malaysia, we cannot decrease our wages, even labor demand increase. Okay, so in reality, if wages increase, okay, labor demand will decrease. When wages increase, labor demand will decrease. That's why many firms in Malaysia they don't like increased wages. Okay, they don't like the government's impose minimum wages. Okay, so why they don't want the government impose minimum wages? Because wages actually contribute to the cost of the firm. Increase wages, increase cost. For the firm, they want to minimize the cost. Look at here. If labor wages increase, they demand less labor. Okay, they will hire more capital. So that's why, okay, the firm in Malaysia, they don't like minimum wages because they feel if the government impose minimum wages, the cost of labor increase. The cost of labor decrease, they hire less labor. So when they hire less labor, they use more capital, meaning that unemployment will increase. Any question, please? Any question, please? Okay, any question, please? Any question, please?
No problem.
Okay, good. Okay, this one example. Okay, for a fixed quantity, as price of labor increase from 1 to 2, firm move along its fixed quantity. Fixed quantity means that okay, move along. Okay, move along. Move along labor demand curve from A to B. Move along from A to B. They hire less labor. They hire less labor. Hire less labor. Okay, increase in output here. Look at increase in output here. Okay, we shift the demand curve. Look at the demand curve. Okay, increase in output will shift the demand curve. So meaning that if this firm want to increase output from Q to 200, they must hire more labor. And the optimal will be C, no more B. So the condition is they must hire more labor in order to increase to Q from 100 to 200. Any question, please? Okay. So, however, is fixed quantity. Okay. So, if cost of labor increase 1 to 2, they hire less labor. They produce in here optimal. No. They produce 100, but the combination of capital and labor in here rather than in here. Okay, so they use less labor. Here. The gap between here and here is less labor. Any question, please? Any question, please? Okay, next. Okay, so this one is the price elasticity of demand for input. Please, this one is capital and labor. This one is labor, elasticity, price elasticity of demand for labor. This one is price elasticity of demand for capital, K. This one is L. So very simple, change in L divided by change in W multiplied by W divided by L. So this is price elasticity, okay, of demand for labor. Okay, so change in K divided by change in R multiplied by R divided by K. This one is, okay, price elasticity of demand for capital, K capital, L for labor. Okay, so what do you mean by, okay, you must remember that what is elasticity? Okay, so this is the meaning of elasticity. Percentage change in cost minimizing quantity of labor. With respect to a 1% change in the price of labor. Okay, price of labor. What about this? Percentage change in the cost minimizing quantity of capital with respect to 1% change in the price of capital. This is the price elasticity of demand for labor. This one is for capital. Okay, this one. Okay, this one is low elasticity of substitution. This one is high elasticity of substitution. Okay, look at this one is here. Q is 100. This one is Q is 100 as well. Okay, 100 as well. If you have low elasticity of substitution, no substitution, so demand curve for labor is inelastic. Even wage increase 1 to 2, you still hire more labor. Look at only 0.4. Okay, 0.4. The difference between 5 and 4.6 is 0.4. You still hire more labor. Why? Because low elasticity of substitution. Okay, give me example of the industry. What industry they have low elasticity of substitution? Even when they should still hire more labor. Okay, what kind of industry? Telling me the industry. Telling me the industry. Give me example of industry.
Maybe cigarettes.
Cigarette? No. Cigarette. No. Cannot be cigarette. Cannot be cigarette. Okay? Cannot be cigarette. We're talking about the not elasticity of demand. We're talking about the elasticity of demand for input. Please. We're not talking about elasticity of demand. Okay, so you confuse, okay, elasticity of demand. However, in this particular topic, we talk about the elasticity of demand for input, capital and labor. So if you talk about the cigarette, wrong. Cannot be. Okay, others, try.
Construction.
No, cannot be construction. Others, try.
Machines.
Construction will be here. Construction will be here. Construction will be here. Others?
Pharmaceutical industry.
Yes, pharmaceutical, good. High technology industry, pharmaceutical, medicine, aerospace, whatever new innovation and new technology. So actually this industry use advanced technology, very advanced technology. Very few people knows about this technology. So that's why, please, if you studying in a very, very high technology industry, actually the percentage you'll be unemployed is very low, because they need you. People in that particular industry need you. So that's why if the cost of labor increase, they still hire you. However, this is the problem. However, during COVID-19, look at during COVID-19. During COVID-19, okay, this is different. Look at high technology industry like aerospace, aeroplane. A lot of pilot will be unemployed now. Okay, this is different during COVID-19. Okay, especially pilot. Even pilot we call low elasticity of substitution. However, because of this industry give impact more during COVID-19, so actually during COVID-19 there will be more unemployed. Okay, this is COVID-19. The different. If normal situation, okay, aerospace will be in here. Okay, look at this one. This one is high elasticity of substitution. This one is like you said, construction, agriculture. Okay, and this one is a common industry. Okay, automobile, electronic firm, electrical firm. They will be in here. Will be here. If labor increase, look at, if wages increase, they hire less labor. They produce the same, but they with hire less labor, they use more capital. Okay. So any question, please? Okay, any question, please? Anybody not understand?
Prof, I have
Yes.
a question.
Yes.
Does this mean during the COVID-19, this theory is not applicable for price elasticity of demand for inputs?
No, it's not mean they are not applicable. Okay, we call it as shock. S-H-O-C-K, shock. During economic, there is many years, many time, okay, economic turbulent, or we call it a shock. Okay, so if you still remember during 1998, 2008, and now is 2019, so this we call it as economic shock. During economic shock, everything will be abnormal. Everything will be abnormal. Okay, as I said before, even industry, high technology industry, they should hire more labor. Okay, during normal situation. However, when it comes to the shock, this industry normally will give impact more. They will impact more compared to the agriculture industry, because people need food every day. Okay, so that's why when we talk about pandemic or COVID-19, agriculture industry will not affected a lot. Okay, people still eat, still need food, still need vegetables. Okay, still need fruit, blah blah blah. So actually, people we hire more during COVID-19 in this particular industry compared to aerospace industry or high technology industry. However, when we talk about glove or mask, during normal situation, okay, the production low, very low, okay, then they will hire less labor. Okay, however, during COVID-19, okay, they will hire more labor, even cost of labor increase. Okay, they will hire more labor. There is, for example, industry like glove and mask. So this particular industry is not high tech technology, not high technology industry, not advanced technology. Yeah, not advanced technology, not advanced as aerospace, not aerospace, airline industry. Okay, any other question, please? Okay, take your break. Okay, take your 5 minutes break. So we'll continue at 9:35. Okay, 9:35. Okay, thank you very much. Okay, see you at 9:35. Okay, class. Assalamualaikum. Hello, class. Hello, class.
Yes,
Class.
prof.
Yeah, are you ready? You ready for our class? You ready for this class? Okay. So this is different between low elasticity of fluctuation and high elasticity of fluctuation. Okay, any problem, please? Please remember this one is price elasticity of demand for input, please. Not just price elasticity of demand. Okay, you remember we study about price elasticity of demand it before, but this particular topic is for input. Okay, we have two inputs here, capital, and we have labor. Okay, any question, please? Okay, any question, please? Okay, next. Okay, please, I think some of you know already about short run costs. Okay, in short run, we have total variable costs and we have total fixed costs. Okay, and also we have variables and non-sunk, fixed and non-sunk, and fixed and sunk. Okay, this is very common in economic. Okay, sunk, non-sunk, and non-sunk for variable, non-sunk for fixed, and fixed and sunk. So what is total variable cost? When we talk variable here, look at the variable here. Okay, variable here. Okay, variable here. So this is total expenditure on variable inputs. Okay, example, we have labor and material. So labor increase, cost increase. Material increase, cost increase. That's why we call it variable. Okay, we have fixed cost. What is fixed cost? Okay, output increase, cost fixed. Cost fixed. Okay, example. Okay, any example? Okay, any example fixed cost? Increase output, cost fixed. Give me one example. Give me one example. Hello, class. Class. Give me one example, class. Hello, class. Are you there?
Prof,
Yes.
plant and equipment.
Plant and equipment. Plant and equipment. Plant and equipment. Example plant and equipment. Machine. Machine. For example, machine. Okay, I give you example machine. Okay, machine. Do you think cost of machine is fixed or variable? Okay, once you produce something, you have machine. I give you example of machine or equipment. Let's say you have a harvester machine. Okay, harvester machine. Harvester. Anyone know or don't know what is harvester machine? You know that? What is harvester machine?
Don't know, Prof.
You don't know. Okay, if you have paddy field, you know paddy field? You know paddy field, paddy PADI, PADDY. Okay, Prince, do you know what is paddy PADDY? Prince?
No,
No, or you don't know?
I don't know, but I know.
Paddy PADDY. PADDY. You know what is PADDY? Okay, what do you eat every day?
Rice.
Rice, isn't it? So rice comes from where?
Paddy.
Paddy. Yes, that's right. This is print. This is paddy. Okay, you eat rice, you not eat paddy. So how you write paddy? Paddy. In Malay, padi. That is in Malay, but in English, paddy. So let's say if you have a paddy field, a paddy field. Okay, once the paddy fields matured, the time harvesting comes, then you use harvester machine. Okay, we call it as harvester. Harvester is we collect paddy from the field, and after that we bring to the factory to process and become rice. Okay. Okay, Prince. Okay, or you not okay? Hello, Prince. Prince, are you there?
Okay, Prof. Yes.
That is paddy. Okay, paddy is your rice. Okay, whatever you eat, rice is a processed paddy. Paddy been processed already, it become rice. Okay, so when we collect paddy from the field, we use harvester machine. So this harvester machine, do you think is fixed or varies? Fixed or varies?
Fixed.
Fixed, yeah. Okay, good. Fixed, yeah. Okay, fixed. Or what about harvester gasoline? Fixed or varies? Varies. So the more you use harvester machine, the more you need to buy gasoline. Okay, gasoline is a petrol. In America, they call gasoline. In Malaysia, they call petrol. Okay, so if you go to America, they not call petrol. They call it as gasoline. Okay, gasoline. So the more you use harvester machine, the more you use petrol. Okay, so petrol is become varies or fixed. Petrol is varies. Okay, varies. Okay, this is variable. This is fixed. So look at this one. Okay, in short run, cost minimization. Okay, we have one fixed input. Let's say capital. K is fixed. Okay, this is the symbol of fixed. Okay, this is the symbol of fixed. Okay, the symbol of fixed is here. Okay, this is the symbol of fixed. Okay, the symbol of fixed. So fixed capital is K bar. I call it a K bar. This one bar, B-A-R. This one is capital K. So K bar is fixed. So short run combination is point is FF here. Okay, in here. So do you think F is the best point should you produce? The best Q you should produce is F, correct or not? I repeat my question. Do you think F is the best should you produce for Q0? Yes or no? Answer is what? Yes or no?
I think no.
Yes, good. The answer is no. The answer is no. Why? Because it is not minimal. It is not minimal. Or in other words, it is not optimal. The best should you produce A. A is the best of combination between K. Okay, because K is constant. Only the price of labor increase. So this firm we hire less labor, and they increase higher K because K is constant. So they produce at A. If the firm were free to adjust all input, so the cost of minimizing combination should be at A, not F. Okay, any question please? Okay, any question please? Okay, any question please? So this is very important. If you are a manager, okay, if you are a manager, you should produce A, not F. Why? Because A and F, you still produce Q0. However, if you produce at F, you are not producing at optimal or at minimum. So actually, you are not a good manager. Any question, please? Okay, look at this one. Okay, look at this one. Okay, actually this one is I have to correct. This one is DBE. This one is okay, BE. Oh, sorry. Okay. Okay, look at this one. Okay, so K is constant. Remember, K is constant. Yeah, look at K is constant. So that's why they call it short run. What is short run? If input, one of the input constant or one input constant, other input will vary. So this is short run. This is short run. Okay, look at this one. K is constant. K is constant. So if K is constant, you produce D, B, and E, short run. Okay, so D you produce at Q0, B you produce at Q1, and E you produce at Q2. So your expression pass is look like this. This is your expression pass. Okay, DBE, DBE. However, when K is not constant, so actually you can produce A, B, and C. So that is we call is long run expression pass. Long run expression pass. Okay. One more question. I like to ask you. You understand or not this concept? Okay, this concept. Okay, short run, the firm should produce at what point? The answer is what? In short run, this firm should produce at what point? Which point? The answer is, come on class. Class, what is your answer, class?
DBE.
No, only one point.
B.
Only one. Cannot be three. Which one?
BB.
B, good. This one. Not here. Not here. Why? Because it is optimal. This short run. Meaning that in short run, you don't have choice. You don't have choice. This is disadvantage of short run. However, in long run, look at long run. You can choose A, still optimal. You can choose B, still optimal. You can choose C, still optimal. This is advantage of long run compared to the short run. Okay, what do you learn from this graph? Anybody can tell me? What do you learn from this graph? What is the moral of story? What is the moral of story from this graph? What is the moral of story from this graph? Hello class. What is the moral of story?
when the capital is constant, the short run and
No? Others try? Simple. You should produce anything, please. The best production in the world should be short run or long run?
Long run.
Yes, long run, please. Long run. Why? Because in long run, you can choose A, B, and C. However, in short run, you don't have choice. If you want to be very minimize your cost, optimal B. If not, you produce D or E. So another question, can all the firm be in long run? Yes or no? Can in reality all the firm in the world be long run? Yes or no?
no.
No, good. Good answer. Good answer. Good answer. Even your firm been in the industry 100 years, sometimes we can still consider you short run. 100 years already in the industry, but you are still short run. Why? Because you still has one of the input is fixed. Is fixed. However, let's say even you are 10 years in the industry, we can consider you long run. Long run. Why? Because capital and labor or other inputs you use are varies. Okay, any question please? Any question please? Any question please? Okay, short run, one input is fixed, for example, capital. So firm can vary the other input. Okay, one input fixed, others vary. So demand for labor will be independent of price. Short run demand for labor will also depend on quantity produced. As quantity increase, labor use increase, holding capital fixed. Okay, this is short run minimization cost. Okay, this example, capital is fixed. Let's say you have Q equal to 50 square, LK equal to 1000. So you simplify L equal to, this one mathematics, okay? This one is mathematics. L equal to Q square here, Q square divided by 2500 K. K is constant. So this is L. This one is L. This one is L. Okay, any question please? Any question please? Any question please? So, okay, so look at this one. Okay, more than one variable input. Okay, you have more than one variable input. Let's say you have three input, labor, capital, K is constant, and raw material M. Raw material M. Okay, so what is marginal rate of technical substitution? Labor to material equal to cost of labor divided by cost of material, M. So marginal product of labor divided by marginal product of material equal to W divided by M. This one is the slope. The slope for this particular graph is minus. This is the slope of isocon. This in the slope is isocos. Is equal to minus, look at this one is W divided by M. Slope is minus W divided by M. So this is the slope here. The slope here. So in this particular graph, you should produce at A. If you produce E and F, you are not optimal. The best production for this particular graph is at A. Okay, is at A. Okay, any question please? That's it. That's it for chapter 7. Any question please? Okay, we go to chapter 8. Okay, I try to take it this one. Oh, sorry, because I have to. Okay, we now in chapter 8. Okay, chapter 8. Where is chapter 8? Yeah, chapter 8. Okay, this is chapter 8. Okay, you can have your chapter 8 in your Google Classroom, please. So in chapter 8, we talk about cost curve, cost curve. Okay, cost curve. Okay, and this particular chapter, we have long run function, we have short run cost function, and we like to see the relationship. We like to the relationship between long run and short run. Long run and short run. Okay, look at the long run cost function. What is long run? Okay, so you minimize total cost to output. What is your output is Q. What is your factor price? W. W is cost, price of wages, price of labor. R is price of capital. So the symbol wages, this one is R. R is price of capital, W is price of labor. So what is the total cost? Total cost for output. Okay, this one is output. This one is cost of labor. This one cost of capital equal to cost of W is cost of labor multiplied by labor. Okay, plus cost of capital multiplied by capital. Any question, please? So L here, L star, K star is long run. What is long run? Anybody can tell me what is long run? What is different short run and long run? Anybody can tell me? Class? Hello class? Hello class, what is different short run and long run? Hello class. Hello class. Can anyone tell me what is short run and long run? Amira, are you there?
Yes.
Okay, what is the difference between short run and long run?
Short run is one input is fixed,
Long run
and long run is all inputs varies.
Yeah, that's good. Very good. So good. Thank you very much. Okay, please remember, remember all the time when we talk about short run and long run. Short run when one of the input fixed, other varies. However, long run all input are varies. So L and K are long run, or in other words, L and K are varies, not fixed. Not fixed. Okay, now look at here. Okay, look at here. Okay, now if you have this one is ISO cost 1, this one is ISO cost 2. Okay, so you have ISO quan 1 million, this is your output 1 million. This one is ISO quan, you have output 2 million. 2 million. So at A, optimal A, you produce at A, you use K1, L1. Okay, you hire K1, L1, you produce at A. However, you produce at B, okay, you hire K2 and you hire L2. So you increase labor, you increase capital, So you can produce more from 1 million, 2 million TV per year. Okay, so if you draw another graph, this is we call is total cost. Okay, please, this is total cost here. This is total cost here. If you draw another graph, total cost from this graph, so you get this graph here. So A here is here. This is optimal. Look at this is optimal. Look at the optimal here. This is another optimal. So you have two optimal point here, A and B. However, the costs are different. Look at this one is cost. Cost TC1. Cost total cost 1 equals to W is cost or price of labor multiplied by labor 1 plus RK1 or price of capital multiply K1. So you produce at A. However, if you want to produce at B, so you have total cost 2. Total cost 2 equal to cost of labor multiplied by L2 plus cost of capital multiplied by K2. So actually you can have more TV, but your cost is also increased. Total cost increase. Total cost increase. Look at total cost increase. Total cost will increase from here. Total cost here to here increase. Or total cost will be look like this. Increase. Increase. Okay, any question please? Any question please? Okay, any question please? Okay, next. Okay, this is example. Okay, this is example. Okay, the question is, what is long run? Total cost function for production Q equal to 50L, half, K half. So when we talk about labor equal to, look at here, we take it here, we take it L. L become on the left hand side and other will be on the right hand side. So if you put it L on the left hand side and others the right hand side, you get it is Q divided by 50, in bracket, multiplied by R divided by W half. This we get it from here. Please, this is mathematics. I told you many times, this is just mathematics. You can do it. You can practice it. After this. From here, if you want to write simply L become Q divided by 50 multiplied by R divided by W power of half. If you want to simplify K from here, you get it is Q divided by 50, multiplied by W divided by R half. Any question please? Any question please? Any question please? However, total cost look like this. This is total cost. This is total cost. If you write total cost using this form equation, you get it this. This total cost equal to W. This is cost of labor multiplied by labor here, Q divided by 50, R divided by W half. This one is here. Plus R is cost of capital multiplied by capital here. Capital is Q divided by 50, W divided by R half. This is total cost. You simplify this, you get it this. You get it this. You simplify this, you get it this. So actually total cost, this particular production is just Q divided 25 multiplied by WR half. Please, this is to simplify from here to here. This is the total cost for this production. Actually, it's just this equation. Any question, please? Any question, please? Any question, please? Okay, any question please? Okay, now look at if W here or W here is equal to 25 and R here equal to 100. Okay, so you plug W in here, you plug 100 in here. Actually, total cost is 2Q. Any question please? Okay, any question please? I repeat, you plug W in here, plug R in here, so 25 multiplied by 100. Okay, 25 multiply 100 equal to what? Hello class.
2,500.
Okay, 2,500. 2,500, this is square root, isn't it? This is square root, correct? Okay. 2,500 square root equal to what? Equal to? Hello class. This is mathematics, very easy. Okay, my daughter just 11 years old. Okay, she can give answer. Okay, what about you? What is the answer?
50.
Yes, the answer is 50. So this one is 50. So Q divided by 25 multiplied by 50, you get 2Q, correct or not? Correct or not?
Yes.
Yes. My daughter just beside me. She said yes. Come on, class. You are master student. Anyone still not understand how we get 2Q here? Hello class. Anyone still not understand how we get 2Q here? Very simple. Okay, now next. Look at, this is a graph 2Q. For example, okay, you want to produce 1 million to 2 million. Okay, if you produce, okay, this is your 2Q total cost. Okay, total cost 1 million, 2 million total cost here. Okay, this is Q output here. Okay, this is your output. You produce output. The more you produce output here, look at, the more you produce output here, because 2Q here. If you have 1 million here, if you want to produce 4 million here, you have 2M here. Because 2 multiplied by 2, you get 4. The 4 here is total cost. I repeat. If you want to produce 4 here, 2Q, Q is, you know that Q is 2. You want to know what is your cost, to 2 multiplied by 2. So you get here is 4. So because this one is Q, this one is your total cost. Any question please? Yeah, any question please? Any question please? Yeah, nice. So we tracking down, or we tracking movement. What is definition long run total cost curve? Okay, this is long run total cost curve. Okay, so it show minimize total cost as output varies. Output varies. What is your total cost? What is your total cost? This is, okay, definition of long run total cost. Okay, so the question, this one question, what does the total cost curve look like if Q varies, W and R fixed? Can anybody answer? Can anybody give me good answer? Hello class. Okay, look at this one. Okay, look at this one. This one is total cost. Okay, the question is, graphically, what does the total cost curve look like if Q varies, look at Q varies, might be 1, 2, 3, 4, 5, okay, this varies, okay, however, W and R fixed. Okay, look at here. Okay, look at here. Okay, we have, okay, look at here, TC, total cost. This one is your total cost. Okay, this one is your labor, this one is your capital. Okay, capital and labor. This one is your total cost here. You produce it here. Okay, Q0, the best production should be here. The combination is there. Look at this one. Okay, if capital is if capital and labor are fixed, okay, are fixed. Okay, so if you want to increase your Q0 to Q1, okay, look at Q0 to Q1. So actually, you can have at this particular point. Okay, you must increase K, you must increase labor, but at proportionate rate, at the proportionate rate, at the proportionate rate. Okay, look at this one. Okay, if you have this kind of K increased by this amount, L increased by this amount at proportionate, okay, at proportionate rate, okay, your total cost it look like this. Okay, look like this. Okay, here is total cost at 0, WL0 plus RK0. And this one is total cost at 2 here, WL1 plus RK1. So your total cost is look like this. Okay, this is, we call it as long run total cost. Okay, if K and L are proportionately, okay, the same. So this is become look like S shape. This is S. We call it S shape. Okay, S shape. Okay, now, how does the total cost curve shift if wages rise but the price of capital remain fixed? Okay, W increase. Okay, W increase. R fixed. R fixed. Okay, it look like this. Okay, it look like this. Okay, it look like this. Okay, look at when W increase. Okay, R fixed. So meaning that you use less labor. Okay, W increase, use less labor, you use more capital. So meaning that, okay, actually B in here. Actually B should be here, A should be here. So the isocon should be there. It is isocon. Okay, isocon should be here. So you produce at Q0. So if wages increase, okay, capital remain the same, you produce at B. However, B and A are similar because they are optimal and produce at Q0. The only difference is combination of capital and labor. In here, we use more labor. In here, we use more capital. Okay, any question, please? Okay, any question, please? Okay, any question, please? Any question, please? Okay, next. Okay, the shift in the total cost curve. Okay, now we like to shift. The total cost can be shift, either shift here or shift there. Shift there. Okay, now when we talk about in this particular example, so total cost shift will be in here, like this. Yeah, this one is before, this one is after. After wages increase. After wages increase. So look at this one is total cost original. This one is total cost new. Right? This one is total cost new. Q same, right? Q the same. You produce at the same Q. This one, you produce at the same Q here. You produce at the same Q. This one, you produce at the same Q. Okay, you produce at the same Q. Okay, any question, please? Okay, any question, please? Okay, next. Okay, how does the total cost curve shift if all input price rise? Rise meaning they increase similar amount. Input price increase similar amount. Similar amount. Okay, look at. Okay, let's say if price of input increase proportionately by 10%. Meaning that, okay, labor and capital increase by 10%, for example. Okay, so total cost curve shift up here. Sorry, total cost shift up here by 10%. Look at 10% here, 1.10. This is 10%. So A to B is 10%. So you produce still at Q0. Q0. Your production is the same. However, the cost is increased by 10%. Okay, any question, please? Okay, any question, please? But you still at optimal. Okay, you still at optimal. Okay, any question, please? Okay, any question, please? A at optimal, B is optimal or not? Yes or no? Answer yes or no. Hello, class.
I think also optimal, Prof.
It's optimal, yeah. Only cost different is 10%, but still is optimal. The difference is only total cost 10%. 10%. Okay, now, what is long run average cost? Okay, just TC, total cost divided by Q. Total cost divided by Q, you get it is average cost. Any question, please? Okay, now, what is marginal cost? Long run. Okay, change in total cost divided by change in Q. Or DTC, you remember? DTC divided by DQ. DTC DQ is marginal cost. I repeat, DTC DQ equal to marginal cost. Any question, please? Okay, any question, please? Okay, next. Okay, look at example here. Okay, Q equal to 50L half KL, K half. Okay, total cost. Remember, this is total cost. Okay, remember, this is Q divided by 25 here, from here. From here, okay? Okay, this is total cost here. This is total cost there. Or total cost equal to 2Q. Total cost equal to 2Q. Okay, now. Okay, let's say you have total cost equal to Q divided by 25, WR half. So if W equal to 25, W equal to 25, here 25, R equal to 100, 25 multiplied by 100, you get it is 2,500. Isn't it? So square root, you get it is, okay, you get it is 50. So Q divided 25 divided multiplied by 50, you get it is 2Q. 2Q. Okay? 2Q. So from here, what is average cost? Answer, please. Answer my question. If I have TC equal to 2Q, What is my average cost, AC? Answer is wrong.
2.
2. Good. Why? Because TC divided by Q equal to average cost. So TC 2Q divided by Q. So Q cancel, you get 2. So the answer is average cost is 2. Okay, now, what is marginal cost? This one, marginal cost. What is marginal cost? What is marginal cost for this total cost? The answer is
2.
2. Why 2? Because DTC DQ equal to 2. So this is the answer. Okay. Any question, please? Yeah, any question, please? Any question, please? Any question, please? Okay, next. Okay, question. Okay, go ahead.
So far, no, Prof.
Okay, good. Okay, now, okay, look at. So this is look like, the graph look like AC and MC equal to 2. This one. Constant. AC and MC equal to 2. Constant. Okay, my question is, good or, okay, in reality, if your production achieve this, AC is look like this, MC is look like this, is it good or bad? The answer is what? Good or bad? Others? Others? Try. Others? Bad or yes? Bad or good?
I think good.
Okay, look at this one. The more you produce Q, you can maintain average cost. Your average cost is flat, even though you produce more. So very few firm can do this, because normal firm, if they produce more, average cost should be increased. However, for this particular firm, when they produce more, average cost constant. In reality, not many firms can do this. If you can do this, it's good. Okay, look at the relationship. Okay, look at. You produce 1 million, you increase to 2 million, you still have average cost equal to marginal cost. But not too many firms can practice this. So what is relationship? This is very important in the production. What is the relationship? Okay, you have cost of labor, you have cost of capital, fixed. Now look at the relationship. When marginal cost less than average cost, meaning that your marginal cost in here, okay, below here, your average cost is up here. So this is marginal cost less than average cost. So look at the relationship. Average cost decrease in Q. Good or bad? Good or bad? This signal telling you good or bad?
Bad.
Good, not bad. Good. Why? Because look at AC decrease. When you increase Q, AC decrease. Signal, this sign telling you good. Okay, next. Look at this one. When MC is more than AC, AC increase. Meaning that in here, your MC is here, your AC is here. Your AC is here, your MC is there. Look at this one. So when MC is more than AC, AC increase in Q. So this one telling you good or bad? Bad, yes. Look at this one. When MC equal to AC, this is the point here. Okay, so it's flat with respect to Q. Okay, flat. Look at flat. Okay, that is the relationship. So in economic, what is the moral of the story? Anybody can tell me? These three relationship, we have three relationship. Number one is MC less than AQ. Number two, MC more than AQ. Number three, MC equal to AC. Okay, what is the moral of the story for this relationship? We have three relationship: MC less than AC, MC more than AC, and MC equal to AC. Anybody can tell me what is the moral of story, the relationship? This. Anybody can try? Anybody? Try it, please try it. Try it because you learn it. Not the story, the moral of the story. Okay, the moral of the story. Okay, look at here. Okay, this one is MC less than AC, so AC is more than MC. Okay, so look at this one. You in this particular AC more than AC, you produce more. Okay, AC more than AC. In this particular, okay, in this particular part, okay, you produce more. AC less than MC. As MC in here, AC is in here. Okay, and at this particular point, AC equal to MC. Okay. Okay. Which area, which part is the best for production? Which one? Is it in here? Is it in here or in here?
At point A.
Yes, good, very good. This is the best production should you produce. Any question, please? Okay, take 5 break. Okay, we meet again at 10:33. Okay, 33. 5 minutes, only 5 minutes. Okay, take a break. Okay, class. Class, are you ready for the third period? This is the last period. Hello, class.
Yes, Prof.
Yes, Prof.
Okay, this is the last period. Okay, now, this is important. Economic and this economy of scale. Economic and this economy of scale is from this particular condition. Okay, we have three conditions. First condition, second condition, and third condition. So in economy, these three conditions, either your company is here, your company is here, or your company is here. Please, and it is very important for the company, for the production. Okay, if you have company in the future, make sure you are in what condition? Either this condition, or this condition, because these three conditions are important. So the practice you establish now in your company, they call it as here, minimum efficient scale. Minimum efficient scale. Okay, what is minimum efficient scale here? Look at, you can maintain minimum AC for many years. This is been practiced for many companies in the world, especially large company, like Panasonic. Okay, now we talk about the iPhone. iPhone. We're talking about the Samsung. Okay, they are all this company. Okay, practice minimum efficient scale. Okay, so meaning that this company can maintain at minimum AC for many years. Okay, for many years. So for many years, you can minimize your AC, but you can produce more. So this is not all the company can do this. Not all the company can do this. Okay, you can produce more. Look at, you can produce more, but your AC is still minimum. However, when you reach here, Q here, your AC increase. So either you stop your Q at here, or you start to build another plant. Okay, this is, we call it as plant. You can stop production here, or maybe you can start to have a new plant. So if you maintain, if you maintain similar plant, your cost will increase. Okay, any question please? Okay, any question please? Okay, any question please? Okay, next. This is, we call it as MES. Okay, MES, remember we talked it last week, minimum efficient scale. Minimum efficient scale. Okay, minimum efficient scale. Okay, now, okay, we talk already return to scale and economy of scale. Okay, this is my PhD. Okay, I give it to you, my article, after you submit your second journal critic. So I will post my third journal critic. So we're talking about the return to scale and economy of scale. Okay, what is return to scale and economy of scale? Okay, look at this one. Increasing return. You increasing return to scale. Okay, and your SC exhibit economy of scale. So meaning that what is return to scale here? Okay, return to scale here. You reach this minimum SC. At the same time, your return is increasing. This is okay return to scale. Okay. Increasing return to scale. We call it increasing return to scale. Remember, we have increasing return to scale, we have decreasing return to scale, and we have constant return to scale. Constant return to scale. Yeah. So increasing return to scale meaning that okay, average cost okay exhibit economy of scale. Okay. SC decrease okay with Q, decrease with Q, okay? So we have another one, this economy of scale, decreasing return to scale. Okay, what is decreasing return to scale? Okay, decreasing return to scale, you exhibit this economy of scale, okay, as SC increase. Okay, what is constant return to scale? Constant return to scale, you have, okay, you have SC flat, okay, neither increase or increase. Okay, it's different between okay, increasing return to scale, economy of scale, or decreasing return to scale, this economy of scale, or constant return to scale and neither increase or decrease with output. Okay, any question please? Any question please? Any question, please? Okay, next. Okay, look at this one. Okay, before that we talk about okay the elasticity of demand of input. Now is output elasticity of total cost. Okay, output elasticity of total cost. Okay, what is output elasticity of total cost? This one total cost. Change in total cost divided by total cost multiplied by change in Q divided by Q. Or in other words, change in total cost divided by change in Q is marginal cost. And TC okay, divided by Q equal to average cost. So output elasticity of total cost equal to MC divided by AC. Okay, if you get less than 1, MC less than AC, okay, so AC decrease, so meaning that you are in the pace of economy of scale. Okay, however, if your elasticity, output elasticity of total cost is more than 1, your marginal cost is more than average cost, so you are in this economy of scale. Let's say if you get 1, MC equal to AC, so actually you are in the flat. Okay, AC is flat. Okay, any question please? Okay, in production, don't do this. Don't do this. Don't practice this economy of scale. All the time you should practice economy of scale. Okay, so the best is here when your AC is flat. Okay, any question please? Any question please? Okay, now short run and total variable cost function. Okay, remember short run, okay, at least one input fixed short run. Okay, what is total variable cost? Okay, we have two costs here. Okay, short run total cost equal to total variable cost plus total fixed cost. So this is short run total cost. Okay, short run total cost. Okay, any question please? Okay, next. This is short run total cost. Sorry. This is total short run total fixed cost. Okay, this is total fixed cost. Okay, why total fixed cost? Because increase Q, cost remain the same. So that's why we call it total fixed cost. Total cost is here. Okay, this one is total fixed cost. Remember, total cost, short run, we have two, total variable cost and total fixed cost. Okay, now what is total variable cost? This one is total variable cost. Okay, when you have production Q, when you have production, there is no cost. So this is total variable cost. However, even there is no production, you have to pay, you have to pay total fixed cost. Okay, there is no production, you have to pay total fixed cost. This is happening in during COVID-19. During COVID-19, when the government asked lockdown, when lockdown, there is no production. However, the company must pay fixed cost. What is fixed cost for the company? Example, fixed cost is rent. Rent. Maybe the company rent a building, a factory. So even there is no production during lockdown, they have to pay rent. Okay, so this is fixed cost. Fixed cost. Okay, now if you add total fixed cost plus total variable cost, so you get total cost. Short run total cost. Here, one STC. Okay, STC equal to TVC plus TFC. Okay, TFC plus TVC, you get here. You get total cost, short run total cost. Any question, please? Okay, any question, please? Okay, any question, please?
No, Prof.
Good. Okay, next. Look at this one. The difference here is R is cost of capital multiplied by capital. This is capital. Capital normally is fixed. Rent. You rent a capital. Okay. So normally capital is fixed. Okay. So the difference here between this STC minus TVC, you get TFC. So the difference between STC and TVC is TFC. So this is the same value is here. Okay, any question, please? Okay, now, understanding the relationship. You can minimize cost. Okay, minimize cost as long as long run, as in the short run, because it is less constraint. There is no constraint. Okay, however, short run total cost curve lies everywhere above the long run total cost. Please remember this statement. All the time, short run total cost normally will be above the long run total cost. Okay, long run total cost. Okay, so look at this one. This is your total cost. Okay, this one total cost for capital. This one total cost for labor. Okay, labor. So this one is ISO cost. Okay, now look at this one is when you increase labor, total cost for labor increase. The same as here. When you increase capital, total cost for capital also increase. So you have a second one. Second one, ISO cost. Okay, ISO cost. Okay. So the same as here. Okay, so ISO cost in here, another one. Okay, let's say you have K is fixed. This one is short run. If K is fixed, okay, you can produce A or you can produce B. Okay, look at this one. This is expression pass. Okay, so in short run, because K is fixed, okay, you can choose to produce A, you can choose to produce B. Okay, A or B. However, in the long run, look at the long run, because in long run, K is varies, you can increase K. Okay, you can produce it here, C. Okay, so if you compare between B and C, C is the best. Why C is the best? Why C is the best? Because C is optimal. And C as well are point of expression pass. Okay. However, A is in short run, but C is the long run. Why? Because K is fixed. However, K is varies. Okay, any question please? Okay, any question please? Okay, any question please?
No, Prof.
Okay, good. Okay. Okay, now. Okay. Look at this one. Okay, now we have total cost here. We have this one is short run total cost. This one is total cost. Okay, K is the long run cost minimizing quantity of K for Q0, right? Q0. So look at this one. So total cost 0. Okay, you produce at Q0. So this is the best. Okay, this is the best point of production A. Okay, point of production you should produce at A. Okay. Okay, K0 is the long run cost minimizing. Okay, of quantity of K for QA. So you produce at here. Produce at here. At C, okay, look at C here. Okay, at C, total cost increase. Okay, total cost increase. Okay, actually this point at C is not optimal. Okay, it's not optimal. Even though you can produce more Q. Okay, you can produce more Q. Okay, so the best you can do, what is the best you can do? You move to here, to B. Okay, but if you move to B, you produce still Q1. However, your cost is increasing. Keep increasing. Your cost is increasing. Look at the cost is increasing. Okay, the cost is increasing. So now we talk about the short run average cost function. Okay, short run average cost function is actually short run total cost divided by Q. Divided by Q. So what is marginal cost function short run? Okay, change in short run total cost divided by change in Q. Divided by change in Q. So in short run, we have short run total cost equal to total cost, and we have short run marginal cost equal to marginal cost. So short run total cost equal to total variable cost plus total fixed cost. Short run average cost equal to average variable cost plus average fixed cost. Okay, so how you get it? Short run average cost equal to short run total cost divided by Q. How you get it? Average variable cost equal to total variable cost divided by Q. How you get it? Average fixed cost. Average fixed cost equal to total fixed cost divided by Q. Okay, any question please? Okay, there is normally you learn from your degree, your degree. Okay, so now look at this one is how average fixed cost look like. look like? The more you produce Q, average fixed cost will be decrease. But they cannot cross Q. They will decrease until very close to Q. This is how average fixed cost look like when you produce more Q. Okay, look at this one, average variable cost. However, average variable cost, when you keep increasing Q, cost will be increased. Cost will be increased. Look at the marginal short run average cost. Okay, short run average cost is average variable cost plus average fixed cost. You get short run average cost. Short run average cost. So this is above ABC. Okay, where is marginal cost? This is marginal cost. Okay, this is, they call it short run marginal cost. Okay, so far any question, please? So far any question, please? Question, please. Hello, class. Any question? No, right. So my question, okay, my question is, how company practice in reality, especially during COVID-19, to minimize average fixed cost? I repeat my question. Okay, during COVID-19, how the company practice in order to minimize average fixed cost? Anybody can answer? Work from home? No. Why is it work from home is the best answer? Okay, I give you an example. Look at the KLIA. If you go to KLIA or KLI2, okay, what is the fixed cost there? Anybody can answer me? What is the fixed cost for KLIA1 and KLIA2? What is the fixed cost? What is the fixed cost? Answer is, all of you must be there, correct? All of you must be been there before, all of you. Okay. So what is the fixed cost for KLI1 and KLI2? Variable cost is electricity, okay, for example. Okay, electricity bill is variable cost. For example, KLI1 and KLI2. So if they use more, KLI1, KLI2, they must pay more electricity. Okay, so during COVID-19, they will not use KLI1, KLI2, so they can save a lot of electricity. Okay, what about fixed cost?
The airport runway.
Pardon me?
The airport runway.
The airport runway. Good. The answer is good. So many fixed costs in the KLIA. Not just runaway. Okay, runaway aeroplane or airplane. Okay, the building space. If you go to the KLI1, KLI2, you enter the building, so there is a space. You can see the space. Okay, the space is very, very large. Okay, huge space. Okay, so this space is fixed cost. Why I said that? Because KLIA1 and KLIA2 must pay this space to the bank if they take a bank loan to build this KLI1, KL2. So interest plus principal borrowing to build that building is fixed cost. So during COVID-19, okay, there is no passenger, there is no airplane take off. Okay, so what do you think? What do you think about fixed cost? Do you think? Okay, management of KLI1, KLI2 has to pay or not? Yes or no? Yes, that's why the government, okay, impose moratorium. Okay, moratorium. Okay, the government gives 6-month moratorium for those as loan from any bank. They don't need to pay 6 months. However, what happened now? Because now the only categories of people can get moratorium is under B40. Okay, if you are B40, you can apply for the moratorium. So meaning now, KLI1 and KLI2 are not B40 categories of income. So meaning that they have to pay. Can they be able to pay? Yes or no? Your answer yes or no? Answer yes or no? Do you think KLI1, KL2 can pay fixed costs?
No, but they need to pay.
No, the answer good. The answer is no. But they have to pay. So they have to get the money from other sources. If they have more saving, then they can pay more. But whatever, if they don't have saving, so they are in trouble. So that's why if there is no COVID-19, all airport in the world, if you go to any airport in the world, normally what this airport do for the space, you can see that. Okay, what they do that in the space, for the space, in order they can minimize the cost of fixed cost. What normally the airport does if there is no COVID-19? What normally the airport does, the airport management does for the space in order to minimize fixed costs? What the management does? Guess. Give me your answer. Guess it. Hello, class. What is the answer? Not sure. Please.
Is it
Okay. Is it what?
rental?
Yes, good. This is good answer. Good answer. You should, this is important, please. If you're doing business, okay, you have a large space, you can go mall, for example, you go to the Sunway Mall, you go to the SACC Mall, you go to the One Utama Mall, okay, Blue Wave Mall, blah blah. So many mall in Malaysia, especially Sunway, okay, very large space. So what the management of this mall does in order to make sure they can minimize fixed costs, they have to rental every inch, every centimeter of the space to someone else. Okay, so if you look at KLI and KL2, okay, look at that. Everywhere, they have to do this rental. Okay, so the rental, the income from rental, actually they can minimize the fixed cost. Okay, even sometimes they can make profit from renting. So in order to minimize fixed cost, do rental. Okay, this is also been done by Mydin. Okay, look at Mydin. If you go to the Mydin, okay, if you go to the Mydin, okay, outside of the Mydin store, a lot of space, large space, and this space normally be rental to the what to the shop or to the owner other shop other than Mydin to rent. Okay, this is method of minimize fixed cost. Okay, fixed cost. Okay, long run average cost. Okay, this is we call is envelope curve. So this is actually is AC. Okay, long run AC. Long run AC look like this. But inside here, it is short run. There is a lot of short run. Look at short run average cost. You produce Q1. Another short run average cost, you produce Q2. Another short run average cost, you produce Q3. So you connect this point here. That is, we call it as long run average cost. Long run average cost. And this we call it as envelope curve. Envelope curve. Okay, look at this one. Okay, how this is envelope curve. Okay, let's say Q here, Q here equal to K half, L half, M quarter, M quarter. And let W cost of labor 16, cost of material equal to 1, cost of capital equal to 2. So you have production of labor equal to Q divided by 8. Okay, M equal to 2Q and K equal to 2Q. Okay, this is the production of labor, the production of material, and the production of K. So long run, okay, the long run, total cost for this curve is total cost, okay, is, look at this one, 16W multiplied by, here, look at Q divided by 8, this one. Okay, 16 is cost of labor multiplied by, okay, labor. Okay, you get it here, plus cost of M equal to 1 multiplied by M, 2Q is here, plus cost of capital equal to 2 multiplied by, okay, Q, K is 2Q here. So you add together here, you get 8Q. Any question, please? Any question, please? So total cost for this particular Q is 8Q. 8Q. Any question, please? Any question, please? Any question, please? Hello, any question? Any question, please? No, good. So if you have 8Q, it's easy for you to calculate AC because AC is total cost divided by Q. So if you have total cost is 8Q, so average cost is 8Q divided by Q equal to 8. Equal to 8. Okay, so this is another example. So if you have short run total cost equal to 8 Q square divided by K, because K short run, K is capital plus 2K. This one is fixed level of capital. K is fixed. K is fixed. Okay, if the level of capital is fixed, K is fixed here. What is the short run average cost? Okay, short run average cost. Okay, look at the short run average cost. Short run average cost, you divided all by Q. Divided by all by Q. You get it here is 8Q divided by K plus 2K divided by Q. Because you divided all by Q, you get it is short run average cost. Okay, any question, please? Okay, any question, please? Any question, please? Yeah. Okay, this is marginal cost summary. This one is summary. This one is average cost. Please According to theory, marginal cost must cross average cost at minimum. This one is at minimum, and marginal cost must cross. This one, the cross here should be at minimum SC. This is according to the theory. According to the theory. So, if you have short run average cost in here, so you have three choice of Q, Q1, Q2, and Q3. Okay, look at. Okay, so this one is short run average cost 1, short run average cost 2, and short run average cost 3. We have 3 here. So the minimum here, this is the best production for this plant. This plant here, you produce Q1. This plant here, you produce Q2. This plant here, you produce Q3. So if you connect this point here, so you get here average cost in the long run. Any question, please? This one is long run average cost. Any question, please? Okay, now what is economy of scope? Okay, economy of scope not the same as economy of scale. Please remember this. Okay, in mathematics, this is economy of scope. This is the equation of economy of scope. Okay, in theory, economy of scope is total cost here. Look at total cost. You producing Q1, Q2, two goods. You producing Q1 and Q2. In similar firm, is less. Look at the word less. Is less than. Look at less than total cost of producing those quantity into single product firm. Okay, actually, when you can produce Q1, Q2 in one large firm, it's better than you produce Q1 at firm 1 and Q2 at firm 2. Okay, because if you produce Q1 at firm 1, cost is higher. You produce Q2 at firm 2, costs are higher. So many firms in the world, they produce Q1 and Q2 at a very large firm. Okay, so this is we call economy of scope. Okay, give me example. In Malaysia, which firm practice economy of scope? Give me example in Malaysia. Firm produce economy of scope. Hello class. Class. Hello class. Can you hear me?
Yes, Prof.
Yeah, okay. Give me example. Give me example in Malaysia, large firm produce two goods. Instead of one firm produce Q1, another firm produce Q2. Okay, give me example. There is a lot of firm in Malaysia. Okay, practice economy of scope. There is a lot. Big firm. Example? Come on, there is a lot. Hello class. We don't have time. Think it, please. Because you are master student. Class. Give me the example of computer companies.
what about Inari? Inari is a chip for computer. Yeah, dia adalah company company yang produce chip.
Okay, look at the Acer company. Look at Acer company. Okay, Acer is computer company, correct? Okay, Acer is a big company. Acer is a big company. Or Dell is also a big company. Apple is also a big company. So actually, this company can produce many version of computer, small, big, okay, blah blah blah. So actually, they are practice economy of scope because they not just produce one version of computer. They produce a lot of version of computer. The same as Apple, the same as iPhone. Look at iPhone, the same thing. They produce a lot of version, not one version. Version of good. Okay, look at the if you talk about food industry. Okay, food industry. Okay, another good example is food industry is look at Pepsi, FNN. Okay, food and beverage, FNN. Okay, look at FNN. FNN, a big company that produce we call it as what we call this? For example, Sankey's, all this Pepsi Cola, Coca-Cola. Okay, what kind of drink this one? What do you call this one? I can't remember how to call this. Okay, so I don't remember. Okay, so in economic we call it as economy of scope because this company not just produce a can of, for example, Pepsi. They have a bottle of Pepsi. They have 1.5 liter of Pepsi. They have, for example, 0.5 liter of Pepsi and blah blah. Not just Pepsi, they produce other brand, for example, Coca-Cola, okay, Sankey's, blah blah blah. So this company we call is economy of scope. Economy of scope. Okay, there is another term in economy we call is economy of experience. Okay, good. Economy experience is advantage result from accumulated experience, learning by doing. Okay, this is example. Experience curve. Okay, another one. Okay, what is experience curve? Relationship between average variable cost (AVC) and cumulative production volume. Okay, this is example. AVC, okay, and N is cumulative production volume equal to A and power of B. Power of B. If A more than zero, A here is more than zero. Okay, constant representing AVC of first unit produced. However, if B, here look at B, between less than zero, more than -1, meaning that they experience elasticity. Percentage change in average variable cost for every 1% increase in cumulative volume. So slope of the experience here is tell us how much average variable cost goes down. Goes down. When cumulative output double, okay? When this one double, and double, okay, what happened to the cost? A, average variable cost. Average variable cost should go down when N double, when N double. So this one is, B is play an important role in order to see either this company has experience curve or not. Experience curve or not. Okay, this is estimating convention. I think I don't touch this one because we must use software, mathematical relationship, but I don't want to touch in here because we are in the ODL, so we cannot use software. Actually, this one is software. Software. Okay, that's it. Any question, please? Okay, any question, please? Okay, Nick, no Fatini, do you have any question, Nick?
So far, no, Prof.
Hadi, do you have any question, Hadi?
No, Prof.
Anis, do you have a question, Anis?
No, Prof.
Arif, do you have a question, Arif? Okay, Amira,
No, Prof.
Nakia,
No, Prof.
Nakia. We have Prince. Well, Prince.
No, Prof.
Prince, good. Prince, do you have any question? Prince. We have also Arif, Prince. Nisa, do you have question, Nisa?
No, Prof.
Good. Liana?
So far, so good.
Good, very good. Cik. Next is Aiman. Do you have question, Aiman?
No, Prof.
Nakia?
No, Prof.
Nabila? Nabila, are you there? Okay, Nabila not there. Nikki?
No, Prof.
Good, Nikki, good. Okay, Nur Zulaika?
No, Prof.
Okay, Prince, are you there? Prince?
Yes, Prof.
Good, okay. Liana? Yeah, Liana Safini, are you there?
Yeah.
Okay, good. Okay, now, okay, this is the end of my class. So next week we start to cover chapter 9. Okay, I I have posted already the slide chapter 9. Okay, in our classroom, our Google Classroom. Okay, look at first, then okay, we will discuss it next week. Okay, so before we have class next week, you have 2 assignments should be submitted. First 19, the second will be 21st. So after 21st, I will post you a new assignment for General Critic 3. General Critic 3. This is from my article, and I don't think so it's very difficult to understand. Then hopefully you can do the best critic for my article. Okay, don't worry about the critic. So just do it as a professional, as a master student. So I don't think so I will penalize you for any critic of my article. Okay, any question please? Any question please? Okay, so thank you very much. Then see you next week from now, 1 week from now. Today is 17, so see you on the 24th. Okay? Okay.
Thank you, Prof.
Thank you, Prof.
Thank you, Prof.
Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Prof.
Bye bye.